Okay, another simple method of providing voltage stabilization in common emitter amplifier is to add an emitter resistance RE. So this emitter resistance is going to provide the necessary feedback. So any change in the emitter current, this emitter resistance will act upon it, and it will ensure that the collector current is going to be essentially a constant value. Okay, that is the purpose of adding this emitter resistance. Can anybody say what is the drawback of adding this emitter resistance? Advantage, the Q point is stabilized, my stability factor value is reduced, the character current variation is almost negligible, it is constant. But what is the drawback in adding this resistance RE? Can anybody say that? What is the demerit of adding RE to this circuit?
The
Think and
loss
say.
of energy when adding
Yes.
resistance.
And okay, when you have power loss, whenever resistance you have power loss. And because of power loss, what is the consequence? The answer is correct. Power loss will be there, but this power loss affects what parameter of your amplifier? This power loss affects what parameter of your amplifier?
So
What are
temperature.
the four? What are the four parameters we are deriving for all the amplifiers? Input impedance, output impedance, voltage gain, and current gain. So this power loss happening in the resistance RE will in turn affect what? It will in
Voltage
turn
gain,
affect
sir.
the yes, it will in turn affect the gain of your transit. Sometimes it might be voltage gain, sometimes it might be current gain. Okay, so just by adding RE, we cannot say it is going to solve all my problem. No, it is definitely going to ensure that the Q point is stable. But because of adding additional resistance RE, it is going to in turn increase the power loss which is happening in my circuit. And this power loss can be seen as reduction in gain. If this amplifier can provide a gain of 1000 without RE, with RE, it will provide a gain of 900. Just for example, I'm saying. So you are losing that's 100, right? So that 100 times the amplification of signal is getting lost because of power loss in this resistor. Even though both the cases stability is very good, but because of RE, my stability is even more superior, but I am seeing the drawback as power loss happening in my emitter resistance RE. So that is I cannot compromise on everything, right? Either you have to compromise on stability factor or you have to compromise on gain. But considering the fact that stability factor is even more important compared to gain, I still add this res- I still add this resistance RE, and I continue with the analysis of my common emitter amplifier. Okay, common emitter amplifier. So as usual, once the circuit diagram is given, we would be drawing the AC equivalent circuit, and from the AC equivalent circuit, we'll be drawing the hybrid model equivalent circuit. That is what is given here. See here, an approximate solution can be obtained by considering the simplified hybrid model equivalent circuit. So here I am not adding any capacitance, so AC equivalent circuit is not required. Only thing will be I'll be short circuiting my VCC. Okay, so separately drawing an AC equivalent circuit is not required for this circuit because I don't have any capacitors in my circuit. Okay, so I directly draw the H parameter model. So H parameter model, it is going to be you will have in the input side you will have HIE, in the output side you will have HFVIB collector the current, and you will have the load resistance RL. See, usually this current source will be coming here and it will be connected to emitter. Emitter is grounded, but here emitter is not grounded. Between emitter and ground you have a resistance RE. Okay, so see the diagram. Between emitter and ground, you have a resistance RE. So this current source will be connected to the resistance. This HIE will be connected to the resistance. You're able to visualize the H parameter equivalent circuit. Maybe I'll show the previous equivalent circuit. See here, you have HIE connected between base and emitter. Emitter is grounded. This HFEIB connected between collector and emitter. Emitter is grounded. But here emitter is not grounded. So you can join this and you will have a resistance here. That is RE. So on the circuit, they have drawn in the other way. So they have drawn this resistor and current source horizontally, and this resistance will move up. So when you compare with the fixed bias and draw the diagram, it will be looking like this.